In this video, we'll look at another example of polynomial functions where we need to find the leading coefficient, degree, and end behavior. This time we have a function of the form f of x is equal to negative 1/2 x times x minus 5 squared times the quantity 2 minus x cubed. Remember that to identify the leading coefficient and degree of a polynomial function, the function needs to be written in standard form. Well, while we could square x minus 5 and then cube 2 minus x and then multiply that whole thing together, it's really not necessary to do that to identify the degree and leading coefficient. Instead, we need to look at what is the leading term of each of the factors that we want to multiply. So the negative 1/2 x remains as one factor, but when we square the x minus 5, it doesn't really matter what we get except for the first term. When we square the x, we would get x squared. Now notice I'm not suggesting that you square each of those terms, right? X minus 5 times x minus 5 is a trinomial, but we don't need to go through all of this. We get x squared and something else, right? And then when we cube 2 minus x, again, the only thing that really matters is what happens to the leading term when it's cubed. And when we cube negative x, we get a negative 1x cubed. So then if we multiply all of that together, it is sufficient to just multiply the leading terms of each of the factors to get negative 1/2 x times x squared times negative 1x cubed, which is a positive 1/2 x to the, we add exponents, so 1 plus 2 plus 3, which is 6. So the leading term of this polynomial function is 1/2 x to the 6th. The leading coefficient is 1/2, and the degree is 6. So this time we have an even degree function whose leading coefficient is positive. And according to the leading coefficient test, that means that the end behavior is going to be the same, right? We know that being positive, it has to end on a positive note. It has to end going up. So being an even degree function, it has to do the same on each of the ends. So it's going to go up to the right and up to the left. In arrow notation, we write that as x goes to infinity, y goes to infinity, and as x goes to negative infinity, y goes to infinity. Now we can find further information about this function by finding the zeros and their multiplicity. Because the polynomial is already in factored form, to find the zeros means that we would set each of those factors equal to 0. So we would have negative 1/2 x equals 0, which when we multiply by negative 2, we get x is equal to 0. And then x minus 5 squared is equal to 0 when x minus 5 is equal to 0, or x is equal to 5. And then 2 minus x cubed is equal to 0 when 2 minus x is equal to 0, or when 2 is equal to x. So our zeros are 0, 2, and 5. Remember that the multiplicity is the exponent of the factor that involves that 0. So 1/2 x, x is raised to the 1, so that's a multiplicity of 1. The 2 comes from this cube expression, so the multiplicity is 3. 5 comes from that squared expression, so the multiplicity is 2. When we have an odd multiplicity, the graph will cross the x-axis at that point. So for the 0 of 0 and 2, the graph will cross the x-axis. But for the 0, 5, it's going to touch or bounce off the x-axis at that 0. So we can do a rough sketch knowing all of this information. We just learned that the zeros were 0, 2, and 5. So the x-intercepts are 0, 0, 2, 0, and 5, 0. The y-intercept, if we plug in 0 for x, f of 0 is 0, so the y-intercept is the origin. Now the maximum number of turning points, remember that that is based on the degree. The degree of this polynomial function is 6, so the maximum number of turning points would be 6 minus 1, which is equal to 5. The domain is all real numbers for any polynomial function. The range we can't quite answer until we know the precise graph, because remember that the end behavior is that the graph goes up, so there's got to be some minimum point for the range to be, and then it goes up from there. So we need to wait on that as well as the other parts of that. So just a rough sketch, and then we'll get the precise sketch. We know that it's going to cross the x-axis at, or be on the x-axis, 0, 0, 2, 0, and 5, 0. And we know what the y-intercept is, also there at the origin. So what do we know? We know to the left it's going to go up, so to the left of 0, it's going to be up, but then we know that it crossed the axis at 0, 0, and then it had to go down to some point, and then it's got to come back up at 2. Remember that had an odd multiplicity, so it's got to cross the x-axis at 2. In fact, with it being 3, it's going to kind of flatten out of that axis. And then it's got to go up to some point. And then we know that the graph has to come back down because it has to bounce off the axis at 5, 0. And we know that the end behavior there is to the right, it goes up. So a very, very rough sketch. But understand that I can get all of that rough sketch just from knowing the behavior at the zeros and the end behavior. To get a very precise graph, we can use a calculator. So I have put some screenshots on this slide so that you can actually see what I did. I entered the function -1/2 x times x minus 5 squared times 2 minus x cubed. And when I graphed it, I realized that the view was outside of the standard viewing window. I looked to my table to figure out what's happening between the zeros, to figure out what values will help me see the complete graph. Now you notice that between the zeros of what? We have 0, 2, and 5 is what I need to be concerned about. So between the x values of 0 and 2, the y values went down to a -8. Between 2 and 5, notice again that it went up, right? And so there's a maximum value of 16 that I see there. And then also to the right of 5, it continues up. So there's no maximum beyond that point. So I need to make sure that I have a window that includes -8 for my smallest y value and 16 for my largest y value. My x-min and x-max of -10 and 10 are fine because 0, 2, and 5 are included between -10 and 10. So I chose a y-min and y-max of -20 and 20 and a y-scale of 5. And so we see that here now on the graph. My window is from -10 to 10 in the x direction and -20 to 20 in the y direction. Notice also that the graph crosses at 0, 0, at 2, 0, and at 5, 0, it bounces off. So I had to figure out what is this minimum point, right, this valley point, and this peak of my graph to figure out the maximum and minimum value and those turning points of my graph. This is where I had to invoke the calculator function of maximum and minimum. I had to do, for the minimum, I had to do the second trace and choose option 4, which is minimum. And recall that to do the minimum, I had to enter a left bound, a right bound, and then a guess. So I had to somewhere be on the left side, and then the right side, and then the guess. And whenever I execute that command, I found that my minimum point is approximately 0.4, negative 17.4 if we round to the nearest tenth. To do a maximum point, I'm going to do second trace and 3. And for this maximum, again, I had to go left bound, right bound, and guess. And so this point is approximately 3.9, 16.2. And then notice that there is another relative max at that 0 of 5, right? It's the order pair 5, 0. So I have the relative minimum points. So the relative minimums were 0.4, negative 17.4, and also 5, 0. And the relative max is at 3.9, 16.2. So the minimum value of this function, the minimum of the function is negative 17.4, but there is no absolute maximum because the graph continues upward, right? But if I had to answer what are the relative minimums are negative 17.4 and 0, but the absolute minimum is negative 17.4. The relative max is 16.2, but there's no absolute max because the graph continues upward. Now, what about increasing, decreasing? So the function is increasing on what interval of x? Notice that we first start with decreasing, and then we get to this minimum point, and then it goes up to this maximum point, then it goes back down, and then back up. So it's actually increasing on two separate intervals. It's increasing from 0.4 to 3.9, and then from 5 to infinity. And where's the function decreasing? So it's decreasing to the left of this minimum point. So it's decreasing from negative infinity to 0.4. And then it also decreased again between the peak and this 0 at 5. So that's between 3.9 and 5.